So today we are going to review for the quiz, but I'm actually going to start by reviewing yesterday's lesson real quick, okay? I'm sure it's on the review, but let's just talk about what would the end behavior look like based on things like degree and leading coefficient. Do you remember this business? This is a book problem. Obviously, I don't know that it's assigned, but number 12 right here says, what degree would this be? Degree 7, and the leading coefficient is, yep, all we really care is that it's negative. So this is how I memorize this, guys. I think to myself, it's an odd degree just like a cubic. I don't know how many squiggles are in the middle, but it's just like a cubic. But it's negative, so I have to do what to my little cubic here? Yes. And I don't know if it would maybe let me rotate that. Oh, I can. There we go. So that's the end behavior. Do you need me to write it out? Okay. Did someone say yes? I can do it. Okay. Thanks. What about this guy? Oh, that one's not important is exactly right. They tried to trick me, and I fell for it. This one is what? Degree 5 with a leading coefficient that is then positive 7 right there. So did I turn that upside down? That's not right. Thank you. Flipping it didn't do anything. It's reflected, not rotated. I don't know if that's a choice. Flip, up, down. Look at there. That's the right end behavior. This one has a positive leading coefficient, so it's that way. I was like, wait a minute, something's wrong. All right. Everybody okay, or did I totally confuse you? All right, state the number of possible real zeros and turning points. What do you think? Degree 6, so a max of 6 zeros are possible, and 5 turning points. Everybody remembers that rule? Okay. Now it says determine the real zeros. What could we do? How? Okay, what's left? Okay, which factors further? Ooh, you guys are speedy. Okay, so the zeros, the real zeros are where? If I said we had to do multiplicity, any of those have a multiplicity? Yes, this is a multiplicity 4. Do you remember that part? Anytime a 0 is there repeatedly, you need to list the multiplicity if it says that in the directions, which I think is what's on this next slide maybe. Okay, apply the leading term test. The leading term test says, can we predict the end behavior? If I ignore all the constants in here, what power is this? Okay, so this is a degree 4. Then what does it say? Determine the zeros and state the multiplicities. So, okay, if I erase this again, what are the zeros in multiplicity for 34? 0, multiplicity 2. Other zeros at 4 and negative 2. All right, can you predict the end behavior for me? This was a positive x to the 4th, right? If we ignored all the... Both ends up, okay? And I have zeros at 0, negative 2, and 4. So I should come from the top. What should I do at negative 4? Y cross. Yes, multiplicity 1 at 0. It bounces. And at 4, it crosses. I don't have any idea if it's got any symmetry going on or anything else. I just drew a rough sketch. I should, from the sketch, be able to tell end behavior and what it's doing near the x-axis. That's about it. All right, 36. What's happening here? If I look at that as an x, the leading term here, well, we can leave it 2, doesn't matter. This one would be squared, and this would be an x. It's still degree 4 and it still has a positive leading coefficient. What's the difference in this one? Where are the zeros? Okay, and which one has a multiplicity? So this time it has a -5, 0, and a 3, and this time the bounce is where? Okay, does the 2 do anything? The 2 out in front? Well, it would make the graph stretch a little bit faster, but in terms of the zeros and the leading coefficient, what would have changed? If that 2 had been negative, would it have changed things? The end behavior, yes. The zeros, it would still cross at those same places. All right, thanks guys for the quick review of yesterday's. The first lesson that's new on the quiz is operations and composition of functions. And these are pretty good examples of the kind that might be on the quiz tomorrow, okay? Now, what would you do if it said to add f plus h? Here's f, here's h. Can I combine any of that garbage? Yeah, I can combine the constant terms, right? Otherwise, I don't care what order you write it in. So if you wrote 3x squared plus 4x plus the square root of x plus 3, but this 2 and this -7 is a -5, so somewhere in there we need a -5. That's the only thing you can combine. Everybody okay with that? Yeah. Yeah, don't try to fiddle around with that and do anything bad news. Okay. G minus F. Guys, this is on here because everybody wants to do this wrong. What can you think that people are going to do wrong? They're not going to distribute the negative, but this class, no one's going to forget that, right? Okay, this says 5x plus 2 minus f is 3x squared plus 4x plus 2. Just so happens there's room near this question where you could probably write it out like this and then distribute and simplify so you didn't mess up. Okay, can anybody distribute and simplify? I have so little room. Do you need me to distribute? Here, how about I do this? It would become plus a negative and a negative back here and a negative back here. Yes? So I'd have a negative 3x squared. How many x's do we have? Positive 1x and a 2 and a -2. That's it. Okay. Where do you want to go to next? This divide one? What's f over g? We should be talking about domain too, because there's a domain question. We'll go back and do that. Actually, let's talk about it real quick right now. Which one of the two that we've done so far has a domain restriction? The first one. And how do you find the domain restriction? X plus 3 must be greater than or equal to 0. Don't forget the or equal to. Okay? And I think this particular question on the quiz, it says in interval notation. Okay? So we get x is greater than or equal to -3. So you'd have -3 to infinity. There's a party in the hall and we weren't invited. So this is the domain restriction actually of h of x, which would also apply to f plus h. Go ahead. I think on the quiz it asks for interval notation, so that would be this one. All right, f over g. All you do is write the f over the g, right guys? 3x squared plus 4x plus 2 over the top of 5x plus 2. Now, can I cancel those 2's off? Poor little kitty. No, don't do it. Okay. Can't cancel anything because nothing factors out, right? It's all glued together with plus signs. There is a restriction you would need to write for this. X cannot equal what? Yes, because 5x plus 2 cannot equal 0. But I write that any messier. So x cannot equal negative 2/5. On the one that's like that, I left a blank, like domain restriction. Okay, so it's not like I'm hiding it from you. And when it's just a restriction like this, it's okay with me. If you want to write it in interval notation, you can, but it's okay to just say x cannot equal negative 2/5. Everybody good? F times G. Oh, I think I'm going to write that down here. 3x squared plus 4x plus 2 times G, 5x plus 2. The directions to this section say simplify when possible. So I need you to FOIL that all out. It isn't that bad. Or just distribute a whole bunch of stuff. What's 3x squared times 5x back here? 15x cubed. Okay, that same thing times the 2 on the back would be a plus 6x squared. All right, we knocked that one out. Now let's distribute the 4x back there. What do we get? 20x squared plus 8x. So that's supposed to be a 2, sorry. All right, now we knocked that one out. Now distribute the plain old 2. 10x plus 4. We good? Simplifies to 15x cubed plus 26x squared plus 18x plus 4. Did I do it right? Okay. That goes right up there. It probably would have been easier to write that one in front and distribute that way, but this way actually worked out pretty well because the like terms were next to each other. But did I confuse you? Trinity, are you lost? Okay. No worries. All right. I'm going to move to this little guy scrunched in here. It says f of h of 6. What do we do? 6 into h, which would be the square root of 6 plus 3 minus 7, square root of 9 minus 7, which would be negative 4. Are we good? Square root of 9 on a good day is 3 minus 7 is negative 4. Okay. Now what? Put that into f. Oh, lovely. 3 times negative 4 squared. Oops. I see a mistake coming up. What do you think? People going to forget those parentheses? Or the squared or something? All right. You do it on your calculator. I'm getting 48 minus 16 is 34 maybe? Is that right? Okay. I know. This is a crazy hot mess. I feel like I forgot. Oh, I still haven't done this question over here. You know what? I'll do it on a new sheet. I know you don't. You have probably room somewhere to move it, but do it on another sheet of paper if you want. We just write the learning targets before we write the quiz, and then once we've wrote the quiz, we go through and write some questions on here that are like it. And we're too lazy to type them just because we want to get it done. All right. Honestly, our original thing was you're going to wean you off this altogether, where we just gave you the sheet and told you this is what you need to know for the quiz. So at least we're giving you something, right? All right. Find m of g of x. What does this mean? G into m. So this mess goes where? In for that x. So our new m of g of x, I'm going to write it like that, equals 2 over what used to be x plus 5, but now in that spot goes 2x minus 1. What does that simplify to? 2 over 2x plus 4. Abruzzo, you are so cruel. Why? Yeah, this does simplify. I don't think the one on the quiz does. 2 can come out of the bottom and leaves this. So what is that going to simplify to? Okay. What? Poor little putty tat. Okay. Nope. Don't cancel anything until it's a multiplication, and then you can. All right. X cannot equal -2. Even if you left it like this, X cannot be -2, right? Okay. Yeah, we're just going to leave it at that. All right. Oh, was there something else I was supposed to do? Oh, this notation, guys, this notation, is this different? Okay, it's the same thing. I just want to be clear because I don't know which way it's written on the quiz. Are we good? M of G of X still means put this back into this. That little open circle is your composition thing, not your multiply thing. All right, moving on. 1.7 was inverses. Says I can determine if a function is one-to-one and know what it means. What does it mean if a function is one-to-one? Or how do you determine if it's one-to-one? What? Horizontal line test, okay. Does everybody know what we're talking about? Okay. So is this function one-to-one? No. Is this function one-to-one? Assuming that that continues to go up. Let me draw that better. Okay, so this one is one-to-one. And what does that mean? Its inverse is also a function. So it could be asked in that way. Determine which of these has an inverse that is also a function, and you would need to figure out if it passed the horizontal line test. Does everybody get what it means? Okay, horizontal line test, if it passes, it means inverse is also a function. All right, then there's 2 questions where you have to find an inverse, and there's one where you have to graph an inverse. The one where you have to graph an inverse, let me just tell you real quick. I give you some kind of a picture. I'm just going to be really, looks like this, we'll say. And I don't necessarily give you any dots, but you can figure out a few dots on it. How would you do the inverse then? Yes, you reflect across the line y equals x, but what is it you're going to do to accurately graph the inverse? If this was -5, 1, you would graph 5 negative, wait a minute, -5, 1, you would graph 1, -5. If this end was -1, 5, you would graph 5, -1, and it should look like it reflected across that line. It's actually a curve, but the bottom line is if you plot 3 or 4 points, you should be able to figure it out. All right, back to the tricky, icky ones that make us want to cry a little bit. I hope not. Sincerely hope not. All right, there are 2 inverse questions. Anybody have a preference which one we do first? The painful or the miserable? All right, I would pick this one as miserable. What do you do first? Okay, so this is currently y, then what? Make it x. So this will say 3y minus 2 over 4y plus 1. This kind of question is not going to go away. If we have to redo inverses, I promise it will be there. It's on the final. That's because this is the one that I want you to get in pre-calc that you didn't have to do before. The ones where there's a y in 2 places. Actually, you did some of these in Algebra 2, but do you remember the process? Cross multiply, then what? Isolate all the y's, and then factor and divide. Does that sound familiar now? Okay, cross multiply, and this will say what? Do you want me to write out all the steps? X times 4y plus 1 equals 3y minus 2. Distribute, and you get 4xy plus x equals 3y minus 2. Now what? Isolate the y's. Anybody? Okay, so we have a 4xy over here. If we subtract 3y, get rid of that guy, equals, what do I want to do with this? This guy doesn't have a y. Is everybody okay if I subtract that over to the other side? Now what? It's an F word. We have to factor. Take out the y. We can't divide by x. Just to show you what would happen if I divided by x, I'd get 4y minus 3y over x equals negative 2 over x minus 1. Is that better? No. What are we doing? If we take out the y, we have 4x minus 3. And over here we have negative 2 minus 2x. What do you want to do now? We're almost there. I don't know. Just checking if you're awake, because I'm not. Thank you. Now what? Just divide by this mess. So we get negative 2 minus x over 4x minus 3. There are equivalent ways to write that, okay? If you changed the signs on the top, you'd have a positive x plus 2, and you changed all the signs on the bottom, you might have a 3 minus 4x. That looks a little prettier, so that's probably how a book would write it. But they're equivalent. That's my job, to figure out if what you did is equivalent. Any questions? If you need more practice on those, might I suggest the 1.7 homework? All right. What about this one? This one's supposed to be only painful, not miserable. Can you try this one on your own? This is y. Change it to the x. Anybody? Add the 4. Divide by 5. Okay. Now, I could get mean at this point, and I'm not going to. We're going to square both sides. Okay. This was a y. This is a y. This is the y. My bad. Thank you. Okay, now what? You okay? Bless you. All right. What I'm saying about me being nice is I'm okay if you don't FOIL this all out. Let's just leave it x plus 4 squared. I suppose you could even leave the 5, but what could we write in the denominator? 25? Could we at least square that and get rid of the squared? What's left over here is a y plus 2, so we would still need to subtract 2 would be a good plan. X plus 4 quantity squared over 25 minus 2 equals y. I'm okay with you leaving like that, okay? Even if you had left it, x plus 4 all over 5 squared minus 2, I would say that's okay with me. Just so you know the steps. Better than simplifying something you can't simplify, right? All right, moving on. You have to analyze one of these guys. There's only one of them on here. And you have to do domain, range, intercepts, continuous or not, increasing, decreasing, and behavior. Just real quick, this would look like this. I don't know what this is. Somebody want to help me? I think one of, oh, but it has asymptote. Somebody type this. Am I wrong, or is this the right shape? Okay. It does say to graph this, guys, but on this particular, there's a little graph there. I'm not, because it has asymptotes, so maybe like this one, or like this one. I think this one looks like a volcano graph. Because I think the one on the quiz has asymptotes, it's not going to graph with nice ordered pairs. Just throw me down something. But on your calculator, it's going to look like it ends. Does it end? Okay. Help me out. What are we doing? Which one you want to do? Let's do one of these two. The third one? Okay, let's do this one. Domain and range. You can say negative infinity to 0 and 0 to infinity. I would even be okay if you said x cannot equal 0. Either one is fine. It doesn't specify that it has to be intervals. Range? Nope. Nope. Bottom to top. Hard bracket or soft? Should have be. It never touches. 0 to infinity. Does everybody get that? Bottom to top? Okay. Is it continuous? And it's just a yes, no. Is it continuous? No. Are any of the ones up there? This one was continuous, right? Increasing, decreasing. I literally write arrows on my picture. This one was going up, yes, as I go left to right, and this one is going down because I get so confused because you're going left to right and you're writing it in X interval notation. Just write the little arrows. Okay, so over here it was going up. So it was increasing from what? Negative infinity to roughly 0. You don't have to worry about a hard bracket on that anyway. And decreasing from 0 to the right or 0 to infinity. What did I miss? End behavior? Oh, that's a good one for this question. Okay, it looks like this on the quiz because I'm lazy and I want to grade it the same for everybody. Okay, what do you want me to put in there? Let's say left. What's the left side doing? As you go off to the left, it is getting closer and closer to 0. Okay, this one would have been infinity, right? This one would have also been 0. All right, on the right end, yes, these two are both 0. This one would have been infinity. Any questions? I think I covered everything, did I? Oh, it says intercepts, I think, on the quiz. This one would have had one at 0, 0, and you could just write it like that way. These both have none. That's that one. This had. All right. I can graph and analyze radical functions. Oh, another one? Really? Do we need to do this one? Well, let's talk about this because this leads to something else. Can you tell me what this would look like if you could describe the transformation? Here's the parent function. What has happened? Stop looking at your calculator. Oh, yeah. Just kidding. That's not the parent function. The parent function is here. Okay, what happened to this one? Left 1. Okay, oops. Yeah, I shouldn't have made that dot. in order, you should really do it like the stretch next, okay? Because if there was a reflection, you'd have to do that before the big thing is, guys, anytime you have a vertical shift and a vertical reflection, the order matters. You have a horizontal reflection and a horizontal shift, the order matters. I think of it as an order of operations question. If I were to put a 7 in here, I would first add 1, then cube root, then multiply by 2, lastly subtract the 4. So that's the order I'm going to state them in. Okay, I would shift left 1 to what does the 2 do? Stretches it. So it's going to go up and stretches it vertically, yes? Up and down. And then it's going to slide down 4. So it's going to be down here, and it's going to go up a little faster and down a little whatever. Okay. So domain and range. Yeah, infinity to negative infinity to infinity, negative infinity to infinity. Increasing or decreasing? Yeah, it is constantly increasing. And negative infinity to infinity, increasing, never decreasing. End behavior. It does not straighten. Mine looks like it does. Well, you already told me domain and range are negative infinity to infinity, so the end behavior must be approaching either positive or negative infinity. The right end is doing what? No, left end, we usually do first, is approaching negative infinity. The right end is approaching positive infinity. It is continuous. The intercepts you'd have to find from the calculator. One would be the y-intercept. You'd put in 0 something, and the other would cross the x somewhere. Can I just move on? Because I'm not sure there's one like that anyway. What? It doesn't show it's continuous? Well, you probably did. Does it look like it has 2 separate branches? It's the window. It's the pixels. It really does hit that point. It's type in a -1. Trace -1. Does it go there? Yeah. It just looks like it's discontinuous. You have to think about the fact that you can cube root anything. So it's not. All right, guys. Here again, we have the easy and the hard. What about this one? Solving the equation. We're running out of time fast here, guys. I got a whole bunch of transformations I want to talk about. How do you solve this one? Add 5 and you get 9. Then what? Cube both sides. Help. 9 times 9 times 9, 729. 20. Oh my goodness, that was a guess. 4x plus 1. Subtract 1 is 4. What? I don't know. Subtract 1 on a good day, 728. If we divide by 4. Okay, thank you. The one on the quiz, I'm going to tell you right now, it's like a 5th power or something. So you think you might get a really big number at the end? Yeah. It's a big, ugly number, okay? So don't freak out. This one. Oh, we're supposed to check this for extraneous solutions. It's cube. It's always going to work. Okay. This one we should definitely remember to check at the end, okay? What? We need to square both sides. Remember, you can graph this on your calculator, find the solution, and check your answer. I'm all for that. But if there's no work that makes sense, it isn't going to be a 5, let me tell you that. Okay, what's going on here? Square this side and we just get x plus 9. But if I write this out, square root of x plus 1 times square root of x plus 1. By the way, the bookwork on this section, there are a couple miserable questions. But this is more like the one on the quiz, okay? It's not great fun, but it's not that miserable either. X plus 9 equals square root of x times square root of x is x. Square root of x times 1, square root of x. 1 times square root of x, 1 times 1. Okay, now what? Can I subtract an x off each side? Gone. Can I subtract a 1 off each side? 8 equals what? Yes, good call. I can combine those and get 2 square roots of x. Now what? Divide by 2. That seems good. Square both sides again. But it's pretty easy, right? Okay, get 16. If I plug it back in, yes, Melanie. Yeah, let me answer that in 1 second here. Perfect question. Okay, this becomes square root of 25 equals square root of 16 plus 1. 5 equals 4 plus 1. Does that seem okay? What I would do, Melanie, is, and I'm not going to take time because it takes me so long to type stuff on that stupid calculator. Into y1, I'd put square root of x plus 9. Is that what that said? Where I scribbled on it? And into y2, I would put square root of x, arrow to the right, so you're not under there anymore, put the plus 1, and then I would find their point of intersection. And the x value at the intersection should be the solution over here. If it intersected twice, which is possible, I did one on someone's homework the other day with them yesterday, and it was one that like started back here, so it crossed, but then it eventually crossed again. So there were 2 solutions, okay? Moving on, we good? Highly suggest you do the homework on 2.1 so you practice those. Okay, oh good, we already did this. Can I skip this section? Because I'm going to run out of time and we got these review babies to do. These review babies. Okay, what are you most worried about this one? Graph analysis. You know what? Instead of doing this and taking time, because we don't have much time, can I just make one up? Okay, I'm going to pretend that this is -1, 4, and this is 5, -2. Okay, I'm going to assume you could find the zeros. I may not even have put the zeros on there. I don't think I did, because I know everybody can find the zeros, okay? What about all the rest of this stuff? End behavior, are we already good? Okay. I found the max and mins. Everybody okay? It says nearest hundredth. Are you going to get it right this time? Okay. 2 decimal places. Unless it rounds, you know, to 0.0 or 0.30, and then you could just write 0.3. But all right. Okay, this is where we get a little foggy. First of all, increasing, decreasing. Do we need the inflection point for that? Up, down, up. So how do you write it? Why not 4? It's X intervals. Okay. Is it increasing again? Decreasing. Okay. Concavity. What do you need? Okay. Yes. We need an inflection point. It has to be somewhere between the max and min. I'm not going to be picky, okay? I'm going to pick that point to be 2, 1. What do you use about that to tell me concave up or down? Yes. Concave up? This way, yes. 2 to infinity. Concave down is that side, so it's -infinity to 2. Okay, can you do this on your calculator and get nice values? I just didn't want to spend time because, you know, it take me 10 minutes to find all those on the calculator. We good? That leaves us transformations, which I'm really worried about. Okay. It says I can describe the transformations Ms. Abruzzo's review here is just, it's like it was on the last quiz, guys. There are literally 3 worksheets over there on transformations if you want some more practice on transformations. One of them is like this, became okay. You got to tell me in words what happened. Can you tell me in words in the order that it should be? The only true order that matters is this negative and the 4. Okay, by the way, but go ahead. Right? Okay, horizontal shift, right 7. Okay, then what? Okay, I would take that, reflect over X because of the negative, vertical stretch by 2. I would have put the vertical stretch before the reflection, but it isn't a thing that I would count wrong, so it's fine. But the vertical shift, that has to come after the reflection, guys. Do you get it? It's not the same, okay? That's why she wrote this, okay? All right, then there is matching. I can match transformed equations to their graph. Please tell me what the difference in this is. This is a horizontal shrink. This is a vertical stretch because anything that happens inside is the opposite of what it seems. Are you okay? What's the difference between these two? Reflect over X, and this one is reflect over Y, which means it flipped that way, left to right. For example, this became this, okay? Difference in these, you're good. Yes, I don't need to talk about that. And the difference in these 2 at the bottom, this one is right 2 and this one is down 2. Okay, I got a whole bunch of fun here. Let's not do that one. Okay, can you tell what happened here to here? Yes, reflect over X is this one, so that would be this one. But this one reflected over, so it would be H of negative X. Oh, I ran out of time to do the fun ones. Guys, the matching is a little bit tricky, okay? If you need more practice, there's a worksheet in the back. Let me stop the recording, but